we are going to create a static structure analysis in Workbench. And the first thing I'm going to do here is define my material. So I double click engineering data. I'll be adding a new material like before, and I'm going to call it the class example material. To define the material properties, we are using linear elastic, isotropic elasticity. So I double click on isotropic elasticity and I expand it in the properties of outline row 4 class example. And for Young's modulus and Poisson's ratio, we have to input the value. But looking carefully here at the units, the default units are SI units, and my problem is using US engineering units. So before I input any numbers, I want to go and change my units. From the pull-down menus, I go to units, and I change that to US engineering. And I want to make sure to display values in project units. Now looking at my table, Young's modulus is in PSI, and I'm going to put here we had a 10 times 10 to the power 6, which is 1E7. For Poisson's ratio, I'm going to put a 0.3.
It's always 0.3 for steel, right?
For methods, if it's not given, we're going to be using 0.3. Correct. I'm going to toggle back to project. And I want to right-click geometry. Please make sure it's a right-click to choose a new design modeler geometry. This will launch design modeler. I can turn on my default planes, X, Y, ZX, and YZ. I still want the axis of my part to be the x-axis. And I'm going to be using extrude today. I'm going to be using it twice. I can create a profile and revolve, or create a section and extrude it. So in order to keep the x-axis as the axis of my part, I'm going to be creating my section in the YZ plane. Remember I mentioned in the design modeler, there are two modes, modeling and sketching. When we use beam elements, we use only modeling. For this example, using solids or 3D geometry, I'm going to be using sketching, and I will be creating a sketch in the YZ plane. So if you look in the toolbar menu, it says here XY plane, ZX plane, or YZ plane. I want to select the YZ plane because we want our sketch or section to be created on the YZ plane, and it is going to become a child of the YZ plane. There is this blue icon that says new sketch. If I click new sketch, I see a sketch created under the YZ because I've had my YZ plane selected. Before I move any forward, you look at the ruler here and it's showing my units in meters. It is my responsibility as a user to make sure that all the units are correct and consistent. So I want to go to units and change that to inches. I'm ready to create my sketch. I can choose to be looking to the YZ plane, and I'm gonna zoom in. So in my ruler here, I see a 1 inch. Remember, our radius is 0.56419, and I want to now to sketch, so I'm going to go from modeling to sketching. And what I need to sketch is simply a circle.
Can you show again how you got there?
How to get from modeling to sketching.
Just, I can go back and forth from modeling to sketching by clicking the tabs. So under sketch 1, and I go to sketching, I'm going to select a circle. And I want to make sure when I'm sketching, you see the constraint signs or symbols that are showing up. If I go to an axis, it shows a C. I really want to make sure that my center is coincident with a point, it's not the axis. So I want to make sure to move close to the origin to see a P. When you see a P, now you're going to click your mouse and move out to create a circle that has a radius of about 0.56 inches. So I'm going to click here, and here is my circle showing in a light blue color, because it's not constrained yet, because I do not define the dimensions. So next, from the sketching toolboxes, I'm going to move to dimensions. And I'm going to select radius. And I want to assign the radius to my circle. You see the color, as soon as I assign the dimension, the color changed from light blue to dark blue. Looking at details of sketch 1, you can see R1, and mine came as 0.413. I want to change that to the radius of AB, the rod AB, so I'm going to change it to 0.56419. Enter. If I toggle back to modeling, you see the sketch here, and it's showing in yellow. I'm going to click generate, and the color will change to dark blue. So we still have 0 parts and 0 bodies. I want to extrude this along the x-axis or normal, in the normal direction, 10 inches. So also in my toolbar menu, I have the option to extrude, so I'm going to click extrude. And you look at the detail view for the extrude 1. And actually I can come here and call this first extrude AB, because this is going to make the piece AB for me. And I'm using my first sketch, and I'm adding material, and my direction is normal. And the depth I want to extrude is the length of AB, which is 10 inches. So I'm going to change that 12 to a 10. I'm going to change my view to 3D so you can see what's going to happen. And I'm going to zoom out. So I see here a preview of where my extrude is going. If I like it, I'm going to click generate. And here comes my first body that makes a solid part. When we use beams, we have a line body. Here I have a solid for my body. Next, I want to repeat the process to create BC. Before I do that, I need to ask, am I going to be using add frozen or just continue to use add material?
Material.
When we use beams, we use add frozen for a good reason. Because we want to make sure that we are able to assign a different section to each line body. But I really do not have a need for that here. So I can just continue to use add material. But first, I need to create a new sketch that has the radius of the section of BC. So this sketch is going to be created on the face of B. So I want to create a new plane, and this plane is going to be created from a face. So the tail of plane 4, I change the type to from face. And it's asking me to select the face. So I'm going to come here and select the front face, which represents point B. And I'm going to say apply. So I get here plane 4.
Can you show that again?
Yes. So I'm going to repeat the process here. I'm going to delete my plane 4. And I'm going to go to create. And I'm going to choose new plane. If you look at the detail view, details of the plane, of the new plane, I can just call it plane at B, right? I'm going to change the type of the plane to from face. And now there is no face selected. So I'm going to go to the base face, and I want to select the face at point B. And I'm going to say apply. Next, I'm going to hit generate, and here comes a new plane. It's called plane at B. Now I'm ready to create a new sketch. I want to make sure that new plane is selected, and I'm going to hit sketch again. I'm going to go to sketching mode, and we are going to draw another circle. I want to be looking at that face here, and I'm going to select from draw, I'm going to select a circle. Again, I want to see the letter P before I do my first left click, and I want to draw a circle that is slightly bigger than the first circle. It is not constrained. I'm going to go to dimension, select radius, select my circle, and assign a radius. This radius needs to be 0.69098 inches to give me an area of 1.5 square inch. It is not yet generated. I can see it here as a child of the plane at B. When I hit generate, the color changed to dark blue. If I change to the 3D view, now I want to extrude that new sketch. So I'm going to hit extrude, and I'm going to call the new extrude BC. I'm using the new sketch, sketch 2, and I'm adding material, and I'm going in the normal direction, but the depth is 12 inches, which is the length of BC. So I changed the depth to 12, and I like what I see, so I'm going to hit generate. I still have one part and one body, so we do not need to form a new part, unlike what we did when we used the beam elements.
Do you know like what the short key is when you're working to like recenter the part in your screen?
Right click with the right click with the mouse and look at the square.
Right click and drag for window. Yeah.
Oh, okay.
But Okay, so now we have a body that is completed and a part that is completed, and we are ready to move on to mechanical. But before I move forward, I want to save my project. So I'm going to come here and save as. And I'm going to call this first 3D example. See. Next, I'm going to double click the model to start mechanical. And please note that I didn't have to show sections to see a 3D because I actually had a 3D part. So it is starting mechanical.
Can you explain again, just like in theory, why in some like examples we just do 2D versus 3D?
This is, the question here is about when to use a 3D model versus a 1D model. It is the same problem that we're solving here, and I'm able to find a solution using a 1D model and a 3D model. In reality, all our parts are in 3D. A 1D model, or even when we did work on the paper and we said we're going to simplify it to a two-dimensional problem, is an idealization. That if we know I can simplify my problem to a one-dimension or a two-dimension problem, of course it's easier and your answer could be more precise depending on how good your mathematical model is. Is my part really behaving like an axially loaded member in tension or compression, or is it doing more than that? So a bar element is capable of handling only tension and compression. A beam element is able to capture bending. The ANSYS beam element can handle tension compression, axial forces, can handle bending in beams, and can handle torsions of shafts, and can handle a behavior of a frame element. But this is going to be very different than if you have a complex geometry that is not behaving like any of the above. It's not a beam, it's not a frame, it's not a truss. Mm-hmm. So then you're going to be forced to use a 3D model. Right. So here is the ANSYS mechanical, and I'm going to go to my geometry. We inherited the part from design modeler, and the first thing I want to do is to make sure I have the proper material assigned. We created a material called class example. So if I look here to my solid, and you look at the material assignment, it got the default structure steel material. If I continue to work without changing that, I'm going to get different answers. So I want to come here and change my material to class example. Next, I'm going to go to mesh. And I can right click and say generate mesh. Click here, and ANSYS now is putting a mesh. And look at what I get. If you look carefully on this mesh, am I still maintaining the cylindrical surfaces? Not really. And the reason we lost that because of the size of the element. This is relatively for the size of my part. This is a coarse mesh. I can continue to use it, but then I'm going to get a distorted behavior because it no longer looks like a cylinder. So before I move any further, I want to refine my mesh. So I'm going to go to the mesh menu, and I do have an option that says sizing. I'm going to click the sizing, and you look here at the default size of the element. And before I move forward, I notice that this is shown in meters. So I want to fix my unit. So I'm going to go to Home, I'm gonna go to tools, I go to units, and I want to change my unit to US customary and use inches. So now you look at the default size of the element, and it is 1.1 inches. So I definitely want to use a smaller size mesh, and this is something that requires experience, and you may also have to refine your model based on the solution to make sure it's converging. For now, we're going to rely on making sure that we have a mesh that fits nicely within the geometry and does continue to keep the look of the part that we're trying to analyze. So for the geometry here, I want to select my part. So I can come here and want to make sure you do not select a piece, but make sure we select the two pieces. And I want to bring your attention here to the option of selecting. There is a smart to select, there is a vertex to select, an edge, there is a face, and there is a body. I want to make sure to select a body so I can select it all at once, rather than picking faces or edges. So now when I apply, I selected one body. And I want to change the element size from the default. Now we know that the radius of AB is about 1 inch. So in order to get a good mesh, I want the element size, I'm going to try 0.2 inches. And now I'm going to hit generate to create the mesh. Generate. And let's look at the mesh we're getting now. Nice uniform mesh, and we're able to capture the cylindrical faces. Next, I'm going to go to my static structure. So we're done with geometry, material, and mesh. I still have two more things in the pre-process, which is to define how my part is being constrained and my loads. So I'm going to start by applying the fixed support at my left end. So I'm going to come here, and I'm no longer selecting a vertex, but I want to select the face that is welded or attached to the face. I'm going to say apply. This is face A, or point A that was fixed. The other side, or the right side, the one that has a prescribed displacement, I'm still going to use the displacement, and I'm going to select my face. I'm going to apply. So I have one face selected, and this is going to displace a distance 0.002 inches in the X direction. And it is not going anywhere in the Y and the Z direction. So I'm going to put 0 and 0. So I have my two constraints. Next, I want to apply my load. When we apply the load in beam elements, I applied it to a vertex. In reality, when you have parts, you don't load them to their center. We don't have access to the center. But it's probably going to be the flange that is going to see the load. So that's what I'm going to be doing here. I'm going to select a force. And now I want to select that face, the green face. I'm going to say apply. And I'm going to define the force using components. And I have a force applied in the x-axis that has a magnitude of 10,000 pounds force. So now we have our two supports, and I have my force applied. I'm ready to run for a solution. So I'm going to hit solve. And I'm looking here on the progress. I'm just going to click cancel. Cancel. And I do have a solution. So I do get a green check mark, meaning there is a solution to this problem. I want to evaluate the solution, so I'm going to hit solution. The first thing I like to check is the deformation. So now when you look at the results, I can select deformation, and I can do the total deformation, and I'm going to hit solve, and we just want to get a feel of what this thing is doing. I'm going to click play, and we see that we're getting the behavior we expected. If you are looking carefully where I applied my loads, it looks like I am excessively deforming that face where the load is being applied. And this is something we couldn't see when you applied the force to a point and use beam element. If I duplicate this results, I say duplicate without results, and I'm going to change that from total deformation to directional deformation. And I want to look at the deformation in the X direction. So I'm going to solve. And you see here, all the deformations are positive, which is what we expected. Next, I go to solution, and I want to tell you here that we no longer have this beam tool. I have a toolbox, and the beam tool is grayed out. The beam tool is grayed out. I do not have an option to show axial forces, moments, like we did before, because I'm not using beams. But from the results, now the stress option is not grayed out. So I can come here and choose a normal stress. When you choose a normal stress, you want to make sure that this is normal to the section or going in the direction perpendicular to the cross section. In this case, that would be the x-axis. If my part was oriented vertically, it will not be the x-axis, it will be the y-axis. But because my part is aligned with the x-axis, or the axis of the part is on the x-axis, I'm going to keep the x-axis. And I'm going to hit solve here. And look at this. I am getting a stress of 8,843.9 maximum. I want to make sure to use probe here and check the stress in the middle of the part or through the part. And it is not the maximum stress that is shown here. But this is more close to what we calculated when we solved this problem using other method, and we got like 5,555. I'm getting here 5,490. Do I have an error? Yes, but this error is like what, less than 1%? For the part BC, if you look here, it's in compression, and I'm getting an axial stress of 3,006, which is very close to the answer we got before. So how about this maximum value of 8,000? I can hit here maximum, and this is going to show me where the maximum stress is. If I zoom here, you see that we do have some stress concentration where there is a change and where the force is applied to the edge. And you look here within the element, I see multiple stresses at this transition. So this is a numerical error and should not represent the stress that you're going to see in your part.
My numbers aren't right, and I think I might have messed up on my my displacement constraint. Is that displacement for this problem like a certain amount? Okay, yeah. Thank you.
I also got the wrong answers.
For the maximum and the minimum, I have different numbers, but for the actual probes, mine match. Is that?
Yeah, we are not concerned at all about the max and min here. We are more concerned about what the realistic numbers that's happening away from points of stress concentration. So as long as your numbers within the members A, B, and BC are close to what we got earlier, you should be good. Another check that we can do is to look at the support reaction. So I can come here and put a probe to look at the force reaction. I'm going to select the fixed support to look at the reaction at A. I'm going to define another probe force reaction and use the displacement at C. I'm going to define another probe to look at the displacement at point B. And for that, I'm going to have to select the face. And please make sure you're selecting a face, the green face that I'm showing here, and not the edge. So to find the displacement at B, remember point B represents a section. So I'm going to be selecting a face and not an edge. And I'm going to say apply. And if I want to look at the displacement specifically in the X direction, I'm going to change the result selection to X-axis. Okay, so I'm going to hit solve. And now we can see the force reaction at A, and I'm getting 5,490. The force reaction at C, and I'm getting 4,509. And the deformation at B, and this is going to be off. I'm getting here a point 0.006 instead of 0.00555 inches. Still, the percent error is acceptable. Again, when we solve this problem using solids, I'm not able to show axial forces, but of course, if I take the stress of 5,490 multiplied by 1 inch, I can get the axial force, 1 square inch for the area. Likewise, if I take the minus 3,000 multiplied by 1.5, I can get the axial force in BC. All right. So with that, we were able to solve the problem we did earlier using a 3D model and solids. I'm going to save my Workbench project. So I'm going to simply click Save. That's my first 3D example. But if I am to share this, I'm going to have to go to File and make sure I archive it. And this will create my WBPZ file, save. And this is the file that you are able to share with others that are going to include all the other directories that has your results and the data that is in it. Any questions?